Hi everyone, my name is Eunha Park. I'm master student at Department of Civil and Environmental Engineering in Seoul National University. Today, I would like to discuss the effect of banana peel ash as an additive on source-separated urine for nutrient recovery. This study was performed under the supervision of Professor Eunha. About 5.5 billion people worldwide don't have access to basic sanitation facilities, and 892 million still practice open defecation. To overcome this problem, UN has set SDG 6 as clean water and sanitation to be achieved until 2020. Especially SDG 6.2 is focusing on the sanitation. But how can we reach this target? As a solution, I would like to introduce urine diverting dry toilet, in short, UDDT system to you. This system is suitable system for low-income countries because this system operates without water nor energy. Urine and feces are separated from the source. This can be used as a good fertilizer after treatment. Let's focus more on the urine treatment part. Urine contains about 95% of water and only little volume of nutrient is available like phosphorus and nitrogen, which we plan for use as a fertilizer. Until now, many have tried to recover this nutrient more effectively in many ways, especially by adding additive. Chemical precipitation is one method that can separate nitrogen and phosphate from the urine. Struvite is the most common chemical product made by adding magnesium source to urine. Magnesium is added to the urine and stirred to crystallized magnesium, phosphate, and ammonia into a 1:1:1 ratio of struvite to concentrate phosphorus and nitrogen in a small volume. Utilization of magnesium containing materials such as MgO and MgCl is not feasible for low-income countries. So, possibility of using nature-based materials as a replacement needs to be investigated. Like seawater, rice straw, and wood ash are a good example of nature-based material that are readily available. They are economical and have low, if not any negative impact on the environment. I choose banana peel ash for this research material because banana are commonly available and are disposed in a significant amount as a waste. Until now, research on utilization of banana peel has been limited for its use in sewage treatment plants. In this study, I will mainly compare wood ash and banana peel ash. So wood ash has been investigated for additive for source-separated urine. However, high contents of heavy metal, it has been limitation on utilization as a fertilizer. This study mainly focused on investigating the effect of banana peel ash as an additive on source-separated urine. Firstly, we investigated the effect of banana peel ash and wood ash on nitrogen and phosphorus recovery from the synthetic wastewater. a further explanation of synthetic wastewater, I will explain in the next page. And secondly, we assess the safety of using BPA added urine as a fertilizer focusing on heavy metals. I will discuss them in detail one by one. So, components of urine vary from person to person and easily change depending on how we store it. To observe nitrogen and phosphorus changes, experiments can be conducted by fixing pH, nitrogen, and phosphorus value for quantity analysis. Hence, synthetic wastewater was used. Additives are used to recover nitrogen and phosphorus. As nitrogen and phosphorus removed from water, their removal rate are marked as a removal efficiency in the results section. Banana peel was obtained by drying the Cavendish banana peel. I dried the banana peel at 40 degrees Celsius for 3 days and burned at 500 degrees Celsius for 15 minutes to produce the banana peel ash. Banana peel ash is referred to as a BPA for convenience during presentation. Wood ash was collected from sauna. I will refer to wood ash as a WA for convenience during presentation. A component of each material is shown in the table. Now I will explain about the experiment procedure. My experiment was conducted as follows. Put additive in 500 ml of synthetic water and stir with magnetic stirring for 5 days. And every day 3 ml of samples were taken and pH level was checked. Samples were then filtered and analyzed for ammonia and phosphate. After 5 days, wastewater was filtered using a coffee filter and sediment was dried for 40 degrees Celsius for 3 days, after which they were analyzed for heavy metals. This is the result, and adding BPA increased the pH of synthetic wastewater. This is really beneficial in struvite generation because pH value above 9.5 is recommended for optimum struvite precipitation. However, if pH is higher than 11, calcium-based precipitation is dominant. So, adding BPA to maintain pH around 10 to 11 is ideal. Optimum dosage for BPA is 10 grams per 500 milliliter, and at that dosage, ammonia removal was 186 milligram per liter, and phosphate removal was 42 milligram per liter. And WA was high pH itself. So, by adding WA into synthetic wastewater lead to increase of pH ranging from 10 to more than 12 with varying dosage. 10 gram per 500 milliliter was selected as an optimum ratio as well as WA2 because the phosphate removal was the highest in 260 milligram per liter, which is like almost 100% from the wastewater. and ammonia removal rate was 162 mg per liter. Compared to WA, BPA can enhance ammonium removal rate by 24 mg per liter, but phosphate removal rate dropped by 218 mg per liter. BPA can replace WA for removing nutrient. However, phosphate removal rate should be improved. So this is the result we observed from the analysis of precipitate, both BPA and WA. Graph in the left show the result of XRD analysis, which identified the solid materials composition. So firstly, we see the BPA first. There is 3 high peak, which has high similarity with Struvite graph peaks. And we can conclude that BPA generates Struvite precipitation, which is magnesium-based precipitation. And secondly, we see that WA precipitation, which has 1 high peak. This shows that WA has high content of CaCO3, which is result in calcium-based precipitation. And in right side there is XRF result. We can clearly see that BPA precipitation has better composition of magnesium and phosphorus and potassium, and the nitrogen composition is still ongoing. In the second objective, regarding the safety for use with respect to heavy metal is an important factor to consider. WA didn't pass both international and Korean standards for fertilizer. However, the BPA meets international guideline, but it doesn't meet Korean standard for copper and nickels. So as a summary, compare BPA and WA. The BPA has higher ammonia removal rate, and adding WA has high removal rate of phosphate. So BPA can be replaced WA for removing nutrient. However, phosphate removal rate should be improved. And the precipitants of both WA and BPA has different characteristic of chemical characteristic. So WA precipitants is the calcium-based precipitation. However, BPA precipitation is the magnesium source-based precipitation, which is Struvite. And BPA meets international guideline for heavy metal for safety use as a fertilizer. Finally, conclusion. So adding BPA as additive to urine is effective for nitrogen and phosphorus recovery. And BPA has low phosphorus recovery compared to WA, which is involved magnesium-based precipitation, such as Struvite. Fertilizer made using BPA is safe to use corresponding to international heavy metal guideline. So until here is my presentation. So thank you for listening, and if you have any question, it will be great for me. Thank you very much.